this problem it is a little bit harder than the other meeting rooms like 1 and 2. But from here, the description is the same. Yeah, so for the meetings, it is the start and the end. But here, the end is not included, but the start is included. Yeah, and also we are also giving this integer n. So n gonna be the meeting rooms from number 0 to n minus 1. All the values of the start I are unique. So meetings are allocated to rooms in the following manners. So those three manners or three sentences is really important for us to understand and solve the problem. So the first is each meeting will take place in the unused rooms with the lowest number. Yeah. So what does that mean? So at the moment, for example, n equals to 2, it means we're going to have two meeting rooms, 0 and 1. Now we're going to have a task. We're going to have a start time and end time, and we're going to use a meeting room. So this means we're going to use the first meeting room, 0, instead of 1. So this is the first question. Each meeting room will take place in the unused rooms with the lowest number. So this is the lowest number. Yeah. Now let's just check the second. So the second is that if there are no available rooms, the meeting will be delayed until room becomes free. So for example, if this meeting room 0 is occupied, so for example from the time 2 to 5, and another meeting, so this means the meeting room 1, so this is for meeting room 0, so for meeting room 1 it is occupied, so for example from, yeah, maybe 3 to 6, this is going to be the start and end time. So this means the two meeting rooms will be occupied. Yeah. So the delayed meeting should have the same duration as the original meeting. Yeah. So the meeting will be delayed until a room becomes free, and the delayed meeting should have the same duration. So for example, I have another meeting. So it is like from 4 to 7. So this is my delayed meeting room. Yeah, because my number is only 2. I only have 2 meeting rooms. It is for those 2. But currently I have another meeting. It is from 4 to 7. So what should I do? So I need to delay this meeting until the first one is finished. So for this meeting, inside of the meeting room 1, this is finished at time 5. So this means from here, I'm going to have another meeting. So instead of 4 to 7, so it's going to be start from 5 to 8. So this is the meaning. Yeah. So the delayed meeting should have the same duration. So 5 to 8, it is the same duration, but the start time is going to be later. It's going to be 5 instead of 6 because this one finished first. Yeah. So this is the meaning. And then let's just check the third one. When a room becomes unused, meaning that have an earlier original start time should be given the room. So this is the meaning. When the room becomes unused, this means after time 5, so this meeting becomes unused. Yeah. Meetings that have an earlier original start time, that should be given the room. Yeah. So this is the earlier. Maybe we have another one. Yeah. Let's just use an example. Instead of 3 and 6, so it is 3 and 5. Yeah. So the meeting with an earlier start time, let's just check. Meetings that have an earlier original start time. So this 2 is an earlier original or start time. Yeah, should be given the room. This means we're gonna use the room 0 instead of room 1 because this is an earlier start time. So this means for the meeting rooms, we need to sort the meeting rooms because after sorting, we're gonna always get the earlier start time for the meeting rooms. Even the start is the same, but this one will be sorted first. Yeah. So this means we're gonna handle this one first, and then we're gonna check with this meeting room. Yeah. Now let's just try to find a way to solve the problem. Actually, this is a pattern. There are going to be many Leetcode problems used this kind of a pattern. It is called 2 heaps. Yeah, it is similar to handling the server. So there's a Leetcode problem about, yeah, there are going to be many tasks, and we're going to have n servers, and all those tasks tasks will be assigned to n servers. It's gonna be exactly the same problem. Yeah. So basically, we need two heaps, and let's just define two heaps. So I'm gonna define as idle and used. So this means for this server or the meeting rooms, it is idle or used. So for the idle from the beginning, it's gonna be the list range of n. So all the n meeting rooms will be idle. Yeah, it means we can use all that. So this used means the meeting room is currently used or it is currently occupied. So we're gonna give an empty array. And let me just prepare a result. So this result will be an array, and inside it will be meeting room numbers. For the first example, it can be 0, 1, 1, 0, or something else. Yeah. So this is the result array. So that's for my final answer. But finally, I just need to turn this result array to a dictionary and find the earliest find my final return, the number of the rooms that held most meetings. Yeah, for this one. Now let me just sort the meeting rooms. So we need to sort it. Now let's just check the meeting rooms. So for start and end time inside the meetings, we're gonna check the used array. So while used and used 0, 0. So this used array inside is gonna be the add time, and with the index. The index is gonna be the meeting room number. So while the add time is less than or equal to the start time, so this means we need to pop it out. So it's gonna be heap pop of the used meeting rooms. So inside, as I explained, I will prepare an add time and the meeting room number. So it's gonna be the index. Yeah. Now I need to push it to the used, because if I pop it out, push it to the idle, because currently I will free those meeting rooms. Yeah, because the add time gonna be less than or equal to the start time. So currently, for example, I'm checking this meeting rooms, and this meeting room has already been sorted, and this is my start time. And all those meetings, the add time is smaller and equal than my current start time. This means all those meeting rooms will be cleared, and we need to push it into the idle heap. Yeah, and we're gonna use this I. So it means all those meeting rooms will become idle. Yeah, and this I is very important. It is for the meeting room. It is for the meeting room number. Now we're gonna check the idle. So if there's idle, definitely I need to pop it out for this meeting room. So I'm gonna use the heap pop. It's gonna be idle. So inside of idle, it's gonna be all the meeting room numbers. So from 0 to n-1, and this I is actually from the used heap, and this I is actually all the meeting room numbers. Yeah. So this is for idle, and then I need to push it. So I'm gonna use a heap push to the used meeting rooms. It's gonna be a tuple with the time. So the time gonna be the add time, and the index is gonna be this I. Yeah. And I need to append it to my result array for this meeting room. So else. So this means there's no idle. All the meeting room is used. Basically, I need to pop it out. So I need to pop out the used. Inside of the used, it's gonna be the add time and the index. So if I pop it out, basically I also need to put it to the result array, and I still need to push it to the used array. Yeah. So currently I have no idle. It means all the meeting room is used. So I'm gonna pop out from the earliest adding time 1. And I still need to push it to the used, because the future time, this meeting room definitely is going to be used. So the time going to be my current add time plus, let me just use this one, maybe the add plus the add minus the start, and with index I. Yeah. So let me explain about this formula here. Yeah. So for this one, so currently this is my start and end time. So for example, it is 4:25. It is coming from here for this meeting, and now here from the heap, I'm gonna pop out this add time. So for example, inside the heap, my earliest add time, it must be more than 4. It cannot be less than 4. If it is less than 4, it's gonna be inside the idle heap. Currently, it must be more than 4:25. Maybe let me just use 4:26 as an example. Maybe this is easier to explain. Yeah. Now I have another meeting. So yeah. So the add time is yeah. Now I have this meeting. So the start time maybe yeah, maybe it is 5, and the add time is 7. Yeah, currently this is my meeting room. Inside the meeting room I have a meeting, so the start time maybe from 5 to 7. So this is the add time, so it is the 7. Yeah, but currently I have another meeting room. It's going to be from 4 to 6. So is that possible? It's not possible because this meeting room is occupied currently. Yeah, so what are you going to do? So instead of 4 to 6, I'm going to update it to 7 to 10, 7 to 9. Yeah, so this is going to be my new add time. So this means my new add time going to be this E minus S. So basically it is 6 minus 4. It's going to be 2. 2 plus this add time going to be 9. So this is my new add time. So finally, I'm going to return the final result. I'm going to set it as an answer. Yeah. Now let me do some process for this result array. So I'm going to use a counter of the result, and I'm going to prepare the answer from the index 0. It means the meeting room 0. Now I'm going to check it. So for I in sorted and d dot case. So this means I'm going to check the index one by one according to the increasing order. So if di is more than the answer, and definitely I'm going to update this I to the answer, and finally I'm going to return the answer. Let me just run it to check. Now as you can see, it works. Yeah. Let me just submit it first. Yeah, as you can see, it works and it's pretty fast. And the time complexity, basically it is n log n, because it is so here is a sorting, it is n log n time. Here we use the priority queue, it is also n log n time. Yeah, basically it's going to be a small number. So for this n log n, so the meeting room's length 10 to the power of 5. This n is a small number. Even this n is a big number, it's going to work. Even this n is 10 to the power of 5, definitely it's going to work. Yeah, currently it is only 100, but for our algorithm, basically it works for n equals to 10 to the power of 5. Yeah, it is n log m. Yeah, let me just explain. So for the meeting rooms, this is all the meeting rooms 10 to the power of 5. So for example, this is n, and now inside the used array, the used is for all the meeting rooms. So this is 100. So it is n log m. M is 100, and n is 10 to the power of 5. So this means even this n is 10 to the power of 5, it's gonna work. Yeah, and here we also have this meetings sort. It is 10 to the power of 5. It's gonna be okay. Now let's just simplify the algorithm. Actually, we don't need to use this line. Maybe we can directly use it from here. So for this I, we're gonna use the heap pop with used. It's gonna be it's gonna be the second index. It's gonna be index 1. Yeah, so here we don't need this. So we're gonna pop it directly and we're gonna push it into the idle heap. Yeah. So here we don't need to prepare this result. We can delete this one. Yeah, because we're gonna put it outside the if else. And here we don't need to basically we don't need to use those two lines. We can also take it out. It's gonna be here. And for this line, we just need to update the add time. We just need to use this one. So e gonna equal to this one. Yeah. Now let me just run it. Now as you can see, it also works, but we simplified the code and we write the code as little lines as possible. Yeah. We can also optimize the result array, but I think that's gonna be okay. We just write it from here, because if we put it here, I think this is more clear, because this result array is for all the numbers for each of the meeting rooms. So for example, this meeting room assign a 0, next meeting room assign a 1, 0, 1. So I think this is more clear, and then I handle it from here. Yeah, I think that's all about this problem. Thank you for watching. See you next time.